we'll start our class, and if other persons they want to join, they can join in the middle also. And if someone asks in the group about the link, then if you see that messages, then share the link. Otherwise, say in the class so that I can share them the link. Because some of the students, what they are doing, they are trying to join in the middle and they don't have link, so they are facing some issues. So okay, so we'll start our class. Today we'll study about the fronts and its types, and after it we'll see about the cyclones. First we'll study fronts and its types. After it we'll see about cyclones, and after that, if we have time, we'll see about the Köppen classification. Okay, Köppen classifications, see, like in 1918, that time that much questions was not asked. Okay, but nowadays, now even 22 papers, 21 papers, Köppen classifications, 1 or 2 questions are being asked. So focus on that also. Only in little some parts are there that you need to know, that some alphabetical some parts are there, small letters, capital letters, 3 words will be there. So that are divided according to basis of what, so that you must know. So okay, so now today we will start about the fronts and its type. So fronts means what? Fronts means, first, before studying the fronts, you all must know about the cold air mass and warm air mass. So about this part you all must know. So about the cold air mass and warm air mass we studied yesterday. So see here, first for studying the fronts, first we'll see how all this, you all would have a study about the tropical belts. So sorry, pressure belts. So in all those pressure belts, we saw that how that high pressure creation is taking places, then low pressure. So all those things, that is useful here also. All those things we will study here. So see here, first what is cold air mass and warm air mass. Suppose see, if this is the part, and from here what is happening, warm air is coming, or here this surface is heated and air is blowing. So here we have the warm air mass. Okay, and some from polar area. See, polar area is what? That is a cold area. Okay, so from there if the wind is blowing on that particular polar area, if the wind is blowing, then that is the cold air mass. Okay, so this is what cold air mass. Then yesterday we saw, you all know that warm air, what it used to do, it ascends. Okay, and where is the cold air, it descends. So now for understanding, see how the front formation happens. So what happens, you all know that when the convergence are happening, of 2 different air masses, okay, 2 different air masses, then what will happen, you all studied even in the plate parts, that if continental part that is less dense, so what it will happen, that will go upwards, and oceanic part which is more dense, that will go downwards, that will try to subside. So in the similar way here what will happen, now here we have the cold air mass and warm air mass coming together, convergence is happening. So here suppose if this is the warm air mass and this is the cold air mass, so in this case what will happen, when this both will converge, so in that case what will happen, warm air mass, you all know that ascends, it will go upwards. So this will start going upwards, and where the cold air mass, what it will do, when convergence will happen, cold air mass will start descending. So it will start going downwards of the warm air mass. So like the formation will start happening. So this is warm air mass, this is cold air mass. So in that what will happen, this sloping boundary, okay, this sloping boundary, when it happens, see, it might go upwards in this much also or like also. So sloping boundary, that when the sloping boundary formation is happening, that particular is known as that sloping boundary is known as the front. Okay, so that is known as the front. So all those definitions, everything are mentioned in the slides. So we'll see that also in the later part. So see now how this front is happening on our Earth surface. So that you can easily understand by our pressure belts. So in pressure belts, you all see, this is our Earth surface. Okay, this is equator. So here what is happening now in this part, this 5 degree north and 5 degree south. Okay, here in this we have 5 degree north and 5 degree south. In this we have high pressure, sorry, low pressure. Low pressure because here heating is there. So low pressure. So in this case, and you all saw in the previous classes that we have a Coriolis force. So how this is happening? That is happening because of rotation of our Earth surface. So because of rotational speed, there is a creation of force. Okay, there is a creation of a force. That force is Coriolis force, and this Coriolis force is inversely proportional to rotational speed. So Coriolis force is inversely proportional to rotational speed. So at this, since we have the maximum bulging at the equator, so here we have the maximum rotational speed. So here we have maximum rotational speed, and at the pole area, see, pole area is there the fixed point. So here at the 90 degree north, 90 degree south, what will happen? We will have the zero rotational speed. Zero rotational speed. So at that point, what will happen? Coriolis force is inversely proportional to rotational speed. So here what will happen? At the equator, we have Coriolis force at 0, and then as it goes towards the northern pole or the southern pole, then what happens? Coriolis force starts increasing, and at the both the pole we have the maximum Coriolis force. Okay. So now because of this Coriolis force, you all study about the deflection of wind. This is deflection. Suppose if this is our Earth, okay, this is equator. So if wind is blowing from this side, okay, now wind is blowing this side. So here what is happening? In the northern hemisphere, you all studied that. In the northern hemisphere, what happens? In the northern hemisphere, it goes rightwards. Wind get deflected towards the rightward. Whereas in the southern hemisphere, wind get deflected towards the leftward. So this Coriolis force is very important in understanding the cyclone part. So there we will study this Coriolis force. So first we will see about the front. So in this part, here we have the low pressure area. Okay. Then again here we have the high pressure. This 30 degree north and 30 degree south. We have the high pressure. Then again 60 degree north and 65 degree south. We have the low pressure. And then at the pole we have high pressure. So in this case, what is happening? Here we have the high pressure. Okay. And this is low pressure. And similarly, same thing happening in the southern hemisphere between the same angle. Okay. High pressure, sorry, low pressure, then again high pressure. So in this case, now see, now wind is blowing from this place, trade winds. So it is blowing this way. Okay. And from here also, it is blowing this way. So in this case, what it is happening? Here we have the low pressure area. Okay. And in the previous classes, we studied that at the equator, we have zero weather, zero, or you can say negative, only little bit of weather appearance are there. So in the equator part, only we have one thing, that is convectional rainfall. Okay. And how that convectional rainfall is happening? That is, you all would have studied in the previous classes about the convectional current. So that what is our solar surface, solar radiation heating directly this surface. So here because of heating only, here there is a circulation of air. Then after that what is happening? Because of that, all those warm airs are rising up. So in this place we have the convection. So only here in this place we have the convection rainfall. So only that weather phenomena is there in this part. So in this 5 degree north and 5 degree south, mostly all other weather phenomena are absent. So even in the front also that is absent, and even when you study about the cyclone, so cyclone is also absent in this 5 degree north and 5 degree south. Okay. Now wind is blowing from high pressure to low pressure area. Okay. Now see, now at the tropical parts we have the warm airs. Okay. We have the warm air, and here what is happening? Sorry, now from the tropical part, in this first we will see the 30 degree north side, 30 degree north and 30 degree south, 35 degree north. So here what is happening at the tropical also we have the warm air. Okay. So from here warm air is going in this side. Okay. Then here we have the cold air. Okay. So from here cold air is coming. So now when the warm air is coming from this side and cold air, so because now there is a meeting of cold air and warm air. Okay. So when there is a convergence of cold air and warm air, so in that case what will happen? Warm air will start going upwards and cold air will start descending. So in that case, that sloping formation, that is known as the front. So in that, now this is for the tropical part. From equator, this full part is tropical. Okay. And here we have little bit subtropical part. Then this part we have the polar area. Okay. So now in this part you can easily know that where tropical front is taking places, where polar front is taking places by knowing the name. Okay. So mostly this front formation where it will happen? It will happen between the 35 degree to 65 degree side. Okay. Because what is happening from here cold air is coming and from here warm air is going. So in this case what will happen? Warm will ascend and cold air will descend. So there will be the formation of front. So now this is the about the formation of front. So all those theory part or everything I mentioned is right, that everything we'll see, and also we'll see the different types of front. Now after seeing the different types of front, in that way you can easily guess the how the tropical cyclone is happening. About the tropical temperate cyclone we study. So temperate cyclone, mostly all those processes in the temperate cyclone are happening because of front part. So temperate cyclone is also known as the frontal cyclone. Okay. And whereas in this equator area, in the tropical part, we won't have that much front formation. So because of no front formation or little bit of front formation, we have tropical cyclone. So tropical cyclone, that also we'll study, and we'll also study about the front cyclone. So now we'll move to the next part. So see here, for conditions. First, what is front? So sloping boundary between the two different contrasting air masses. If the same air mass comes, suppose if cold air mass are coming and they are converging, then what will happen? They will mix with each other. Then again cold air mass. So full it will be cold mass. So there should be the different contrasting air masses. Okay. So in that case, that cold air mass and warm air mass would be there. Okay. And when the convergence happens, you all know the warm air will go up, cold air will descend. So in that case, that sloping part is known as the front. Okay. And for that, there are three conditions. Okay. So temperature is the first condition. How temperature? See, warm air mass means it will have the high temperature. Cold air mass it will have the low temperature. So that temperature and condition is the one part. Okay. So this is the first condition. Then we should have pressure. So that pressure difference must be there. So how those pressure difference are there? See here. Now you all know that if high temperature is there means there will be the low pressure, and if the low temperature there means there is a high temperature. So pressure difference also should be there. So that is also one condition. Then it should have the humidity. You should have the moisture content. Okay. All those airs, they should have the moisture content. So this is the third condition. So this is about the conditions of the front. Okay. Now see, you all have the, now we saw that pressure base part. So pressure base part from the polar area we have the easterly wind blowing, and from the subtropical area as it is going to the temperate part, there we have the westerly wind blowing. So in that particular part only front formation happens, and mostly all those front formation happens in the winter season. So mostly all those front formation happens in the winter seasons. And see what will happen as front formation is happening. Then after that what will happen? Now this warm air is rising up. This part is going down, cold air. This is warm air, this is cold air. Okay. Now front formation is happening. That formation of front is known as the frontogenesis. Okay. And frontolysis. When what will happen? When cold air descending this side. So after sometimes cold air will occupy all these places and warm air will be parallel to it. Okay. So in that case what will happen? There will the death of the front. So that death of front is known as the frontolysis. So this is about the frontolysis and frontogenesis. So now we have totally 4 types of front. One is warm front, one is cold front, and one is occluded front, and another one is the stationary front. So in that first we will see about the warm front. So warm front means what? Where warm air mass will be active, okay, and they will enter in the territory of cold air mass. That means warm air mass will be active and cold air mass will be silent. So in that case what will happen? Now this is cold air mass. This is our cold air mass. This is warm air mass. So cold air mass will be silent at its place. Now when the warm air mass is coming and converging, so in that case what will happen? That warm air mass that will start ascending. So when it starts ascending, so there is the formation of this type of slope. Okay, and we saw that this type of that sloping boundary is in the front. Okay, so now there is the formation of this type slope. So that is the front. So that front formation due to the warm air mass is known as the warm front. So that is about the warm front. So in this part also we'll see about, see, in warm front we have some cloud formation also. So we'll see about all those formations also. So see here. Now see, for the warm front, what should be the condition? It should have a gentle sloping. Okay. See, here we have the gentle sloping. Okay. It's not like totally steep type, or like we have the, it's not like totally perpendicular, or like we have the like 80-degree type. Okay. It have like, you can say it as a 60-degree, 45 to 60. So that gentle slope is there. Okay. So it should have a gentle slope. Okay. Then that slope should be that warm front will be taking place for the long period. Okay. And in this case also what will happen when we have the gentle slope, warm front. So when the rainfall happens, that rainfall is gentle. Okay. That will not due to formation of cumulonimbus. Cumulonimbus clouds you all studied. That when the rainfall takes place due to cumulonimbus clouds, so there what will happen? There will be thundering. There will be thundering. There will be, okay. So in that there will be the heavy rainfall. But in this case, in the warm front, we won't have the formation of cumulonimbus cloud. So here what will happen? See here. Now you all know that strata is the down part, lower part. So in that case, what will happen? And when the warm front is happening, so in this part we have the nimbo formation of nimbo stratus cloud. Okay. Then next we have the alto stratus clouds. So see, why we saw that for the front formation we should have the moisture content. Okay. So when they have the moisture content in the front, so what will happen? When it goes upwards, so hygroscopic nuclei will be there. So all those moistures, they'll go and settle down on the hygroscopic nuclei. Then we have the formation of clouds. Okay. So in this, at the lower part, we have the formation of nimbostratus cloud. Okay. Then next we have the formation of altostratus clouds. So alto means what? Middle part. So altostratus. Then at the upper part we have the cirrostratus cloud. And then at the highest part we have the cirrus cloud. Okay. So in this case, you must remember this arrangement of all those clouds. Okay. So if they ask, like, if you want to arrange the clouds and study the questions carefully about this part, like previous year in the 23 second paper or 23 first paper, this question was asked. Okay, for arranging these clouds, and in that, see, nimbostratus was given, altostratus option was there, cirrostratus option was there, and cirrus was there. Okay. So now, if you would not have a study about the front, then no one would have been able to answer the correct answer. See, because in front we have studied that we have the highest cloud as cirrus, that is the highest. Then middle we have the alto. Then low cloud we have the strata. Okay, and name, if they would have a study about this one and the name part, so they would have answering like they would have got confusion that to mark whether cirrus stratus, cirrostratus as the highest cloud or the cirrus. In that case, they would have got the doubts. So now in this case, see this diagram carefully. So okay, so in this way, clouds formation are happening, and this warm front, what happens? That occurrence happens like it will be spreading to a large distance, 100 kilometers to 2000 kilometers. So in that case, this front will happen 100 kilometers to 2000 kilometers. Okay, and in the warm front we have the no lightning and thunderstorm. Okay, because we don't have here the formation of cumulonimbus clouds. So here we have the gentle sloping and also the gentle rainfall. Then we have the long period rainfall, and that front formation also will be for the long period, and we have the without lightning and thunder, means there is no formation of cumulonimbus cloud. We have the formation of all these clouds. See, nimbus means we all studied that nimbus means that is a rain bearing cloud. So because of nimbus we will have the rain. Okay, so this is about the warm front. Now next part we will see about the cold front. So how this cold front is happening? So here what happening in the warm front, we say that warm air mass is more active. In this case, cold air mass will be more active. So now in this case what will happen? See, now here in this part what it is happening? Here we have the, see, now here warm air is just blowing. Okay, warm air mass is blowing. Okay, and from here now cold air mass is active. The cold air mass is coming from this side. So now in this case what will happen? When the cold air mass is coming from this side and cold air mass is active, so now that when it is blowing like in silent manner, so in that case what will happen? There is a sudden, so that when the convergence will happen, so in this case what will happen? This particular warm air mass, this will be what, it will be ascending. So in this case what will happen? There will be a steep type. So there will be sudden rising of this warm air mass. So it will become in a steep type. So in that case what happens? When it becomes in a steep type, so there the cold air mass, that means cold air mass is active. So here this front formation is known as the cold front. Okay, so this front formation is known as the cold front. Okay, so in this what happens? In this cold front we have the heavy rainfall. In this only we have the cumulonimbus cloud formation. So see here, now it is rising in a steep part, and also it is carrying moisture with it. Okay, so it is going up. As it is going up, what is happening? After near the tropopause, what will happen? It won't be able to go upwards because it won't have that much capacity. So they will start deflecting. Now in this case, our warm mass is going up. So from here again warm mass will be supplied. So here when the hygroscopic that nuclei is there, what moisture getting settled, and there what will happen? Due to this warm mass, it is going directly upwards. Okay, so here there will be the heat loss in this part. Okay, there will be the latent heat of vaporization. Okay, that means what? Heat loss will be there in this part. So what will happen? Then again this clouds will be going up. So they will go to a maximum height and they will deflect before the tropopause, and they will deflect and they will take a larger shape. And don't forget about the cauliflower shape in the cumulonimbus cloud. Okay, so they will take a larger shape like a cumulonimbus cloud, and then after it, when they are not able to suspend, so due to gravity pull, when they starts raining, so in that case what will happen? There will be the heavy rainfall. So there will be a heavy rainfall in the cold front, and that rainfall is for the short period. Okay, not for long period like warm front. And that formation will happen in the short area. Warm front we saw that formation will be happening in the larger area like 100 to 2000 kilometer. But whereas in this part formation is happening in the short area, because see, it is rising directly steepwards. Okay, like a steep, it is rising directly. So it will have the short area. And you all know that when we have the cumulonimbus cloud formation, that means there will be the thunderstorm and also the lightning part. So this is about the cold front. So cold front is what? It should have the short area. It should have the short area, yes. Then heavy rainfall is happening, and in that cold air mass should be active. So because of that, what will happen? When they will converge, that time what will happen? That time warm front will rise in a steep type, and there we'll have the formation of cumulonimbus cloud. Then due to cumulonimbus cloud, we have the heavy rainfall, and that heavy rainfall will be for the short period. And then in the cold front, we'll have the short area, and then we have the thundering and lightning in this part, because we have the formation of cumulonimbus cloud. So now that was about the cold front. Now about the occluded front. So what is the occluded front? So occluded means you all would have a side, that means you can say it as like a hidden part. like you can say, or obstructing part. Yeah, you can say it as a obstructing part. Okay. So now in this occluded front, what it is happening? See, this is a cold air. From here, warm air is coming. So in this case, what is happening? Warm air will just spread, and in this case, cold front will be cold front will be spreading. Okay, and warm front will be rising. So what will happen? This cold front will occupy all these places, and warm front will be rising like this. Okay. So in this case, when the when the cold front occupies all the down descending parts and warm fronts goes upwards, so that front formation happens. That is known as the occluded front. So here what will happen? That temperature, mostly that condition will be due to the temperature increase. Okay. So this warm occluded front occurs when the cold air mass completely uplift warm air mass. So that means what? This cold air mass is completely occupying this place, and warm air mass will lies in this upper part. So that is the occluded front. And what is meant by stationary front means fourth front. That is stationary front. Stationary front. That means what is happening when the convergence are happening. But that means you can say that even convergence are also not happening. Here this is a cold air mass, and other warm air mass is directly parallel. Warm air mass is parallel. So there is no convergence or anything. So in this parallel type, there will be no front formation. So that is known as the stationary front. So this is about the occluded front, about the stationary front. All these definitions are given in these slides. So just go through it and have a clear understanding of all these different types of front. Okay. Now see, front formation, what when the front formation we are having that is known as the frontogenesis, and that frontogenesis conditions all everything given that it should have convergence of two distinct air masses, and frontolysis is what? Dying of those front formations. So that is the frontolysis. So see, now in this case, see, when we study about the cyclone, there we see that when we have the cyclone formation in the northern hemisphere, there we have the anti-clockwise direction. Like cyclonic formation, we have the anti-clockwise, and in the southern hemisphere, we have the clockwise formation. So that part we will study in the cyclone part. Okay. So general characteristics, all those characteristics which are okay. See, the frontal activity is invariably associated with the cloudiness and precipitations. Okay. So there we know that if they have the warm air with the moisture, so there will be the formation of condensed particles. That means that there is the formation of clouds. Okay. And there, if clouds formation will be there, then from there will be the precipitations also. So in that case, we'll have the rainfall. Okay. The intensity of precipitation depends on the slope of ascent and amount of water vapor present in the ascending air. So this is all about the different types of warm front and cold front. So here see in this area we have the different types of frontal. So see front, that all those front formation is happening due to the low pressure and high pressure only. That we saw that there is one condition. So low pressure and high pressure means what? Low pressure means it will having the high temperature, and high pressure means it will having the low temperature. So see how this formation is happening. So from here what is happening? Here we have the creation of low pressure. Here we have the warm air coming. From here we have the cold air. Then this part it is going up. So there what is happening? There is a front formation is happening in this case. So a stationary part means what? Tie, no clear wheeler. That means what we saw that will be parallel to each other. So there will be no converging. So in that case, that is the stationary front. So all those front definitions are there in this slide. So just go through. So see, stationary front. When the surface position of a front does not change, so when two air masses are unable to push against each other, so that is where the stationary front formation are happening. So whether along the stationary front are cumulonimbus clouds, and we have the uplifted air. So that overrunning uplifted air of the warm air along such a causes frontal precipitations. Okay. Then we have the frontal cyclones also in these parts. So just see all those weather of all those fronts are mentioned in this slide. So just go through And remember that these particular weathers are from. Okay. Then in cold front, all those definitions are given. And cloud formation along the cold front. We have the cirrus clouds also. Then we saw that about the cumulonimbus clouds also. Then we have the lower desert alto cumulus and alto stratus also. Okay. And at actual front, dark nimbus and cumulonimbus clouds cause heavy showers. So in this, see, we have the nimbus cloud, then we have alto. So see, nimbus clouds mostly it will be the downwards part, means low part. So stratus we are adding. So remember that nimbus mostly it will be the low part. Okay. Then alto, middle part, cirrus, and nimbus, only one nimbus stratus, cumulonimbus part is that will be the highest cloud. Okay. So remember that one. Then a cold front passes off rapidly, but the weather along it are violent. So this is all about the cold front. And when the cold front happens, there we have the formation of tornadoes, that is cyclones. Okay. Then all those warm front weather conditions, all those everything are given. Okay. And about the occluded front, we say that see when they will be converging, then that time what will happen? Like a V-shape formation first it will happen. So cold air mass will start descending, it will be coming down, then this will be going up. Then after that, finally what will happen? This fully downwards pass will be by cold air mass, and then this upper part will be the warm air mass. So in that case, what will happen? There will be a formation of occluded front. So this is all about the front formations. So now we'll see about the cyclones. Then after the cyclones, we'll see about the Köppen's climatic classification. So in the fronts part, you also just go through the weather formations also. That also important. Even by the understanding concept part also, you can easily understand that what type of cloud formation are there. But some types of cloud formation that you need to remember. So that in that case, just have a glimpse through it. So when you see all those slides, so there you can easily recall that what type of formations are there, what type of cloud formations are there. Okay. So that was all about the front formation. Now we'll study about the cyclones. So are you all able to see about the cyclone part? Can anyone confirm me whether you all able to see the cyclone part or not? The new slides of cyclones, tropical cyclone, temperate cyclone. Guru Vishnu, can you confirm me whether you are able to see this slide?
Yes, sir. Yes, sir.
Okay. Thank you. Just mute yourself. Okay. So now we'll see about the cyclone. So in this cyclone, we'll see about the tropical cyclone, temperate cyclone, and the polar vortex. So in this part, see, for understanding, if you want to have the better understanding, in these slides, I have mentioned about the difference between these both cyclones. So difference between temperate, tropical, and temperate cyclones are mentioned in this slide. So for the better understanding, if you just study all those differences, then you will be easily able to understand that how those temperate cyclone is happening and how the tropical cyclone formation is happening. Okay. So now we'll see about how the tropical cyclone formation is happening. So this you all can easily see from the diagram. First we'll see from the diagram, then after we'll go to the theory part. So see in this part. In this part, see pressure belt is why I say that pressure belt is very important, because pressure belt is useful in all places. Even in oceanography also pressure belt is useful. So that's why understanding of the pressure belt was the most necessary part. So see here. Now we have our Earth. Okay. Now here we have the equator. Okay. And at this 20° north and 23.5° north and 23.5° south. Okay. These both parts are known as the tropical area. So these both parts are known as tropical area. So in these both parts, water located in these areas are known as the tropical water. So if the cyclones happening in this place, then that particular cyclone is known as the tropical cyclone. And for the occurrence of the tropical cyclones, and although you all should remember the one part that we studied that between the 5° north and 5° south, here at this part, we won't have any cyclone formation. So in this also comes in tropical part only, but we won't have any cyclone formation in this part. Okay. And so see here, for the formation of tropical cyclones and how these cyclones are happening nowadays, there is a, like you say, repeatedly occurrence of the cyclones. So that cyclone is happening due to the global warming. That cyclone is happening due to the global warming. So in this case, see, now we have the high heating of the earth surface. So now because of that, what is happening? Now by understanding cyclones, you will be able to understand that how because of global warming, we have the cyclone formation. And nowadays we have the repeatedly cyclone formations. Okay. So in this case here, first for the formation of tropical cyclones, there are some conditions. First, how the formation is happening. First, we'll see that part, and after it, we'll see the all those conditions for the formation of tropical cyclones. So see here, how cyclone is happening. This is our earth part. Okay. So here what is happening? Here in these areas at the equator we have low pressure. That means high temperature there. Okay. And from all other side, now here low pressure there. From all other side, high pressure is coming. Okay. From different direction, different side, we have the high pressure coming. So in this case, what will happen when the high pressure will be happening, and you all know that at the equator there is, at the equator in the tropical part there is a warm air will be blowing. So when that warm air is blowing, and this case now you all know that wind blows from high pressure to low pressure. So from here all those airs will be coming. So all those airs will be blowing in this part. So when that blowing will be happening, so there what will happen? This warm air, you all know that ascends. So in this case, what will happen when the warm air will be blowing in these tropical areas? So here what will happen? Now due to the high pressure from all those directions, so due to high pressures from all those directions, there what will happen? There it will start rising, and in this case, what when they will rise in a spiral manner, or you can say in a circular manner, cycle manner. Okay, in that way they will start rising. Okay, so when that rising starts happening in that way, and for this you all know that temperature is inversely proportional to pressure. So you all know that how that high pressure is happening and how those low pressure is happening. So you all know that part. Okay, so now in this, what will happen? Due to high pressure from the all directions, and remember this tropical cyclone will happen mostly what? Only in the water bodies. Okay, water bodies will what? It will happen only in the ocean parts, oceans and seas. Tropical cyclones occurrence won't happen in the continental part. So continental part means when the tropical cyclone is coming to the continental part, that means what will happen? After that it will start dying. Means what? Tropical cyclone will start finishing. Okay, so when it reaches the land surface. So in this case, what will happen? Now see here. Now pressure is applied from all those directions. So here it will start rising in a spiral manner, or you can say in a cyclic manner. So now when it will start rising, so then now when that wind is blowing in the oceanic part, so oceanic part means it is confirmed that that warm air will carry moisture with it. Okay, so that warm air will carry moisture with it. So when it is carrying the moisture with it, that means when it goes upwards, so after near the tropopause area, they won't be able to go upwards. So they will start reflecting, and all those moisture they will start settling down on the hygroscopic nuclei part. So there is the formation of clouds. Then after that, when they are not able to suspend themselves, when they are not able to carry their overweight, so after that, due to gravity pull, they'll fall down, and then there we have the rainfall. So now in see this case, now because of spiral, because of high pressure from all those sides, it will start rising in a spiral manner. Okay, and here we should have the intense low pressure. Means what? Here you should have the high temperature. Okay, now in this part, now here we'll understand how that due to the Coriolis force, it is turning into right. Sorry, due to Coriolis force, you all know that wind deflects into the rightwards in the northern hemisphere, and in the southern hemisphere, it is deflecting towards the leftwards. So now in this case, we will understand that how the cyclonic formation is happening, how they are moving in the northern hemisphere in the anti-clockwise, and in the southern hemisphere in the clockwise. So see here, when the rising is happening, okay, when the rising is happening, so now we are in the northern hemisphere, okay. Now when we are in the northern hemisphere, so see here, due to Coriolis force, what will happen? Due to Coriolis force, when we are in the northern hemisphere, first we'll see about the Coriolis force. So Coriolis force means what? This is our Earth surface, okay, and this is our tilted part, and here we have the equator. So now in this, when wind will be blowing from this side, you can see in the diagram here, when due to the rotation of the Earth, we have the Coriolis force, and Coriolis force is maximum at the polar edge. So that you must remember. And now in this part, what is happening? Our Earth is rotating from west to east. So tropical cyclone also, that we will be knowing that how that tropical cyclone is happening. So that also, in that you will be able to guess the directions. Okay. So now you see, in northward directions, in the northward hemisphere, what happens? Due to Coriolis force, wind deflects towards the rightward. So now in this part, what will happen? When they will deflect towards this was. Now wind is blowing this side, high pressure, low pressure, high pressure to low pressure. So in this case, what will happen? So wind will deflect towards this side, and whereas in this part, wind will deflect towards this side. That means rightwards it is deflecting. Okay. And similarly in this, in the southern hemisphere also, they are deflecting towards the leftwards. So in that way, all those formations are happening. Okay. So now that is because of Coriolis force. So now in this, because of Coriolis force, what is happening? Now see in this part, because of Coriolis force, we have the deflection of wind. So the when now this is a low pressure area. From all other parts, we have the high pressure coming. Okay. From all other parts, we have the high pressures coming. Okay. So now in see in this part, so in this part, what will be happening? These are the high pressures. Okay. Now wind is blowing from this side. Okay. When the wind is blowing from this side, and we are in the northern hemisphere. Now don't take in the southern hemisphere. We will study now in later. So now in the northern hemisphere. So when the wind is blowing from this side, and when it goes like this, means what? In the northern hemisphere, we have that due to Coriolis force, it deflects towards the rightwards. Okay. So it will deflect towards the rightwards. So again here, deflection will be towards the rightwards. Again here, deflection will be towards the rightwards, and here also will be deflection will be towards the rightwards. So in this case, what will happen? Now wind will be blowing towards lines. Okay. So in this way, wind will be blowing. So now in this way, after that, only it will start from the spiral part, cyclic part. Okay. So now here, what will happen? Now you all can see here. So due to the rightward deflection in the northern hemisphere, you can see the direction here, rightward deflection. So here what is happening? Anti-clockwise direction is happening. So this is the northern hemisphere. So this how the in the northern hemisphere cyclone formation, when the tropical cyclone formation happens, or even the temperate cyclone formation happens, so in the northern hemisphere they move in the anti-clockwise direction. So remember this one. Then in the southern hemisphere, what is happening? So southern hemisphere means what? Suppose if this is a low pressure area, from this side we have the high pressure coming. So now in the southern hemisphere, what happens? They deflect towards the leftwards. So from here, if wind is blowing, they will deflect towards the leftwards. Here also leftwards. Then again here they will deflect towards the leftwards, and here also leftwards. Now we see the point how wind is blowing. So wind is blowing in this way. Wind is blowing in this way. So now in this way means what? They are blowing in the clockwise directions. So due to that, we have the cyclones in the southern hemisphere in the clockwise direction, and in the northern hemisphere we have the anti-clockwise directions. So for the cyclones, if the effect is happening, so you must remember that one more condition is that Coriolis force also affects the formation of cyclones. So that also you must know. Okay. So that is about the anti-clockwise and this part. Now in this part, see, in the equator part, the tropical area in the equator part, why cyclone is absent? Why cyclone is absent? So see here, you all know that at this part we have the Coriolis force 0 and we have the maximum rotational speed. So maximum rotational speed is inversely proportional to the Coriolis force. So here in this part we have the Coriolis force minimum very less. You can say it is 0 point. So due to the absentee of Coriolis force, so here what will happen? Here we won't have all those spiral formations or cyclic formations. So because there will be no spiral formation, cyclic formation, so there will be the absence of cyclone in this equator part, that is between the 5° north and the 5° south. So now see here, these cyclones, what is happening? These cyclones are named. They have the different names. They are the same tropical cyclones only, but they have the different names in the different parts. So Indian Ocean, that is known as cyclone. In the Atlantic, it will be known as the hurricane. Then in the Western Pacific and South China Sea, we have the typhoon. Then Western Australia, we have the Willies. So if the cyclone names they will ask, so you must know all these names because it might come from matching. So Western Australia is what? In the Australia, if the cyclone is blowing, is what? Willy. Then South China Sea and Pacific Ocean. So China's name is coming. So China means typhoon. Okay. Then in the Atlantic Ocean. So Atlantic is what? You all can see that ocean will be like Europe, between the Europe and America area. So there Atlantic Ocean we have. So there hurricane will be. That if the cyclone happens, that will be known as the hurricane. And cyclone, original cyclone name is the part of the Indian Ocean. So they are known by different names in the different parts. Okay. Now see here. Conditions for the cyclones, for the tropical cyclone. Okay. Conditions for the tropical cyclone. Okay. Don't get confused with temperate cyclone. Okay. These are the conditions for the tropical cyclone. It should have a large sea surface. Okay. And their temperature should be above 27°C. Okay. Somewhere it might be mentioned like 26°C also. So remember that one also. So first condition is what? It should have a large sea surface area. Means what? Mostly water bodies should be there. Okay. Water bodies. And there should be maximum to less. So less continental part should be there. Okay. And that temperature in that sea surface area, it should have above 27°C. So now you all can see, due to global warming, we have heating of our earth. So heating of our earth means what? Ocean part also getting heated. So there we have the increasing temperature. So you all know that when we have the temperature above the 27°C, then there we will have the creation of cyclones, tropical cyclones. So large sea surface temperature, large sea surface area should be there, and temperature should be higher than 27°C. And presence of Coriolis force should be there. So that we all saw that if Coriolis force will be not there, then see all these 5 conditions should be there. If any one of these conditions are missing, that means there would be no formation of cyclones. So you must remember that part. Okay. So presence of Coriolis force should be there. Then a small variations in the vertical wind speed should be there. Why small variations? Suppose see, now the wind is going upwards. Okay. So there what will happen? If there are variations in the wind speed, suppose if a wind speed like jet stream is blowing, you all know the jet stream is blowing in upper troposphere part. Okay. Like you can say it like 6 to 12 kilometer or 8 to 12 kilometer. So it is blowing in that part. Okay. And if that jet stream is blowing in the ocean, that oceanic part where cyclone formation is happening. So there what will happen? Now if the cloud formation are happening this side, when the jet stream is blowing, and you all know that it has a speed like 200 to 350 kilometer per hour. So due to high speed, what will happen? It will blow up all those clouds and it will take with it and it will place it somewhere. Okay. Then there will be no formation of cyclones. So that's what small variation in this vertical wind speed should be there. Okay. Then there should be pre-existing low pressure area. Low pressure area means what? It should have high temperature. Okay, here we saw that temperature should be above 27 degrees Celsius. So it should have the extreme low pressure. So high temperature if we have means we have the low pressure area. Okay, and on the fifth condition is that upper divergence should be there above the sea level. Means what? Upper divergence means what? If the air is blowing upwards, so here what will happen? Here we have the cloud formation, that all those moistures will go and settle down on the hygroscopic nuclei, and there will be the clouds formation. And then after that, what happens when the cloud formation happens? Now you know that due to high temperature, it is going upwards. So high temperature is there means what? When that water is heated. Okay. So when it will go upwards, now it is in the water vapor type. Okay. When it will go upwards, you all know that temperature decreases. So when it will go upwards means what will happen? There will be heat loss. That latent heat of vaporization will be there. So what will happen? Cloud formation will be there. So due to that latent heat of vaporization, so warm air will be in this part. Okay. See, from this side, it is going upwards. You can understand it. It is going upwards. Okay. So what will happen? All those clouds will start getting this side. It will start going through this side. Then we start deflecting this side also. Okay, due to the heat loss. And in the middle we have the warm air. So they will start deflecting this side and this side. Okay. So this is known as divergence. So upper divergence above the sea level is there. Okay. Now see about this part. We'll see. In this part, in the cyclone, you will study about the eye. Okay, and eye wall. So that we'll see here itself. See here what is happening. See here what is happening when the warm air is rising. So here water is heated and it is going up in the water vapor type. So when it is going upwards, so here what is happening? Hygroscopic nuclei is there, and after near the tropopause area, they won't have that much capacity to go upwards to cross the tropopause area. So they'll start deflecting. When they will start deflecting is in either side they will start deflecting. Okay. So here what will happen when all those clouds are there? Now that on the hygroscopic nuclei we have the formation of clouds. Okay, because that moisture should be going settling down. And what will happen now? These are in the water vapor type. When it is going upwards, so they will be cooling down. So cooling down is what? They will start turning into the liquid. So when they will start turning into liquid, so there is the heat loss in this part. Okay. So heat loss in this part will be there is what? Now in this part what will happen? In this middle part, warm air will be blowing. So when here warm air is blowing, and here we have the settling down of all the clouds, that all the deflected clouds. So in this case what will happen? So see here we have this part. So these clouds will deflect. So here we won't have any clouds formation here, and here we have the warm air moving in this part. So this warm air what will happen? They will start sinking. Sinking was in this area it will be sinking. So in this area what will happen? Now it will be sinking, and from here also warm air is going up. So in this case what will happen? This part will be fully warm and there will be no formation of clouds in this part. So during the cyclones what will happen? If the cyclones occurs, so these parts will be silent. So these parts will be calm. Okay. And in these parts, so these parts we have the, now again warm air breathing. So this deflection will be happening. So their surface will be increasing either sides. Okay. So in these both sides we will have the rain, but when these parts we won't have the rain and we won't have the any wind blowing. So in this part, so what will happen? We have the calm type. So calm will be there. So this particular where we have the heat loss, that particular is known as the eye. So remember this is known as the eye, and this particular wall, this wall is known as the eye wall. So this is the eye wall and this is the eye. So remember this one, and remember that when we have that warm air going up, so that between part in the eye part we won't have any occurrence of the cyclone. Okay, so this part will be the calm part. So in eye part we have the calm area. So that everything are mentioned in the slides. That everything we just studied. So we have the clear understanding of all those parts. So these are the conditions of the required for the cyclones. Okay, so all those conditions I have mentioned. So see, in these parts, we all saw that latent heat of release will be there. That means what? Heat loss will be there. And this warm air again, they will be sinking. So now in this case, what will happen? So in this case, these area will be I wall and this part will be the I. Okay. So remember, this part will be I and these areas will be the I wall, both sides. So this will be I wall. So this is about the cyclones and how the tropical cyclones are happening. You all should know about all those conditions. Okay. And we studied that in northern hemisphere it goes anti-clockwise and in the southern hemisphere it goes clockwise. And see why tropical cyclone when it is reaching the surface, Earth surface, that means what? Land surface, continental part. So there will be what? Okay, someone confirm me whether my slides are changing or not, because I got a message that slides are not changing. Ines, confirm me whether slides now it is in a good source of latent heat or not. Ines, are you there?
Sir, it is
Sir,
a tropical cyclone and temperature cyclones.
It stopped in the which part?
Tropical cyclone, temperate cyclone.
Okay, sorry. But you all were able to see all those diagrams, no? Which was I was trying?
Yes, sir.
Okay. Okay, now is it changing?
No, sir.
Just wait a minute, let me see. Okay. So you all confirm me whether now slides are changing or not. Now you all can see the tropical region part.
Yes, sir.
Okay. You all can see the occluded front, all these parts. Okay. So now okay. So now anyone confirm me whether we are in the slides of tropical region or not. Okay.
Still in tropical region, sir.
Okay. So see here. Now in all those previous slides here, we saw that in the tropic parts we have the formation of cyclones. So that is another type tropical cyclone. So in this 5° north and 5° south, we have the absence of cyclones, because here we have the absence of all the Coriolis force. So here no cyclone formation we have. Okay. And for formation of all those tropical cyclones, see, you all understood about how that formation happening in the anti-clockwise and how those cyclones moving in the clockwise in the northern hemisphere and southern hemisphere respectively. You all understood about that part? In doubt in that part? So see, in tropical cyclone, okay, see here, in this part, what is happening? See, it will be rising in a spiral way, okay, because due to the high pressure coming from the all sides. So here we have the intense low pressure. So because of that, what it will be rising in a spiral type, okay. And due to Coriolis force, what will happen? Now suppose wind is blowing from this side. So here what will happen? Wind is blowing for, then here what will happen? Here you all know that due to Coriolis force, what happens? Wind get deflected towards the rightwards. So similarly here also it get deflected towards the rightwards, and similarly here also it will get deflected towards the right. So in all those, when it will get deflected, and you all know that it will move in a cyclic manner. So when you all find this point, so see, it is blowing in this part. So like in a rightward it is going. So it is going this way. Then again here we have the deflection. So here this again. Then again here also we have the deflection. Here also we have the deflection, and here. So again so now it is moving in the like a cyclic manner. It is moving, and it is moving anti-clockwise. So in the northern hemisphere, due to Coriolis force, that deflection of wind is there. So because of the deflection of wind, when the cyclic formation is happening, so through that you can understand that in the northern hemisphere we have the anti-clockwise direction of moving tropical cyclone. Okay, and similarly in the southern hemisphere we have the clockwise. Why clockwise? You all know that in the southern hemisphere wind get deflection towards the leftwards. So because of leftwards deflection, we have the clockwise. So similarly, that also you can understand. Now suppose see, wind is blowing from all those directions. So here what is, since it is turning leftwards, so here leftwards, then here leftwards formation will happen. So similarly in all those cases, when you all join all those leftwards parts, so what will happen? It will move in this part. So this part is what? It is moving in a cyclic manner. So this is about how it is moving in the clockwise direction. Okay. So this was all about the because of which type all those formation are happening. See all those how that clockwise direction are happening, how those anti-clockwise direction is happening in northern hemisphere. So that everything we saw from the diagram point of view also. Then see from this diagram you can easily understand. Now why absent? Why tropical cyclone is absent in this part, that equator, that 5 degree north and 5 degree south? Because of absence of Coriolis force. Here Coriolis force is 0. Okay. So because of 0 Coriolis force, we have the absence of this part. So see, if Coriolis force is 0 means what? There will be no deflection of wind. So then there will be no clockwise or anti-clockwise formation. So in that case, what will happen in this? If rainfall happens, so that rainfalls will be due to the convectional rainfall. So that will be due to the convectional rainfall. Then different names of cyclonic parts. That cyclones are named by the different names in the different areas. So all those names are here. Then see, in these conditions, all those are mentioned. So all those parts you must be clear. Okay. So this, see, first condition is that for the formation of tropical cyclone, first condition is what? It should have large sea surface area and temperature should be higher than 27 degrees Celsius. Then presence of Coriolis force must be there. Then a small variation in the vertical wind speed. See, if we have the jet stream in that vertical part blowing, then that time what will happen? It will take all those clouds with it and it will place it somewhere. Then we won't have any cyclone formation. Okay. So it should have small variations. Then there should be a pre-existing low pressure area. And also it should have the upper divergence above the sea level. Then only there will be the formation of cumulonimbus cloud. Okay. And how this clouds formation is happening, and how which part is known as the eye, which part is known as the eye wall. So see here what is happening. Now when this formation is happening cyclic manner, so here wind is going upwards. So here what is happening? It is sitting down on the hygroscopic nuclei. So when it is sitting down, so again there is the heat loss in this part. So latent heat of vaporization is there in this part. So then what is happening? Here again there is a release of warm air in this part. There is a release of warm air in this part. So here what is happening? Now since it can't go above the tropopause area, so it will start get deflecting. So all those clouds will start get deflecting and it will take the formation of lice, like a bigger shape. Okay, in the both sides. And here in the both part, what will happen? In these both parts, it will be silent because here now warm air will start sinking. So in this part, what will happen? So where it is sinking from which part that warm air sinks, that part you know the eye. So in this part, what will happen during the cyclonic time? This part will be silent. Okay. So this part will be the calm area. Suppose if someone traveling in the ocean area, okay, and if we have the cyclone, so when they reaches this cumulus nimbus part, when they reaches these parts, okay, when they reaches this part, so what they will feeling? They have the like different types of weather phenomena. All those occurrences are happening. They have the high rainfall, and they will be feeling like they have the something that is blocking their way. Means what? Something pushing them back. Okay. Whereas in this area, when they go in this part, so they will be silent. Okay, there will be nothing occurrence. So here they will be feeling free. Okay, again when they process this part, again when they comes to this part, then again that same thing will be happening. So this part is silent, you must remember. So in this upper part where the warm air is sinking, that is known as the eye, and this part will be calm area, and this parts, this joining wall type area in this part, that is known as the eye wall. So this is about the eye wall. And this how the cumulonimbus clouds are formation are happening in all these cyclonics. Even in the temperate cyclone also we'll be having the cumulonimbus clouds. So see, all those are mentioned here. Now see here. Now good source of latent heat. So here what will happen? Ocean's water having temperatures of 27 degrees Celsius. Then only if we have the temperature above this part, then only as the warm air goes up, then only there will be the heat loss. So when there will be heat loss, then there will be the deflection of all those clouds and they will be growing in the sizes. Okay. So when that growing will be there, then there will be the formation of cumulonimbus clouds. Okay. And the depths of warm water extending for the 60 to 70 meter deep supply. So that depth of warm water should be 60 to 70 meter deep supply. So this is also one more condition. So remember this part also. Okay. So enough moisture and latent heat of condensation should be there. Okay. Let's see one question. Why tropical cyclones form mostly on the western margins of the ocean? Why it is happening on the western margins? See here. Because in the eastern margins, from the other side, if lands are there, okay, so because of lands, if lands are there, then there will be like because of land formations, so there where when there will be no presence of water, so that what will happen, all those cyclones will die themselves. So because of warm ocean currents, okay, so mostly all the tropical cyclones occurs in the warm ocean currents. So that you must know. Why are tropical cyclones are very rare on the eastern margins of the ocean? Because cold currents are there on the lower surface. So you all know that when we have the land area, so from there rivers will be coming, fresh water will be coming, and also all those sediments will be coming. So rivers and rainfall, all those waters will be coming. So that will be what somewhat cold type. So that because of that cold area, we have the very rare cyclones in the eastern margins of the ocean. Okay, and this is tropical cyclones is very necessary for understanding the El Nino and La Nina. So that El Nino and La Nina that we study in the oceanography part. Okay, and why they weaken on the landfall? Why? Because see, on the land when they reach the landform is what? There will be no water on this part. So here what? There will be no formation of clouds in the upper part. So cyclone movement will be not there. So when they reach, so only thing that they will get the heavy rainfall in this part also. But after this, what will happen? They will start dying. So tropical cyclones weakens when they reach the land area. Okay. So about the police force we studied. So this was all the parts of tropical cyclones. So early stage, all those everything are mentioned. So you see, condensation releases the latent heat of condensation, so making the air warm. So that in upwards pass we studied there, and in the similarly in the downwards pass, so it will make the air warm. Then that will warm will rise. Then in the upper part when it goes, there is the settling down of all those moisture spot. Then after that, what will happen? When they will be settling down this part, there will be latent heat of deprivation, means what? Heat loss will be there. Then because of that heat loss, it will be diverging, it will be deflecting, that deflection will be there in the larger sizes. So then after that, we have the formation of cumulonimbus clouds. So through this diagram also you can understand. So this is all about the tropical cyclones. So tropical cyclones we saw about the eye. So eye is a roughly circular area of light winds and fair weather. So we saw that this particular part is the calm area. That means what? It will have the light winds and it will have a fair weather. Okay. There is little or no precipitations and the sky is clear in this part, in the eye area. Sky is clear and there is no precipitations. Okay. Precipitations means what? That rainfall is coming down. So that is the precipitations. Okay. The air is slowly sinking and is heated due to the compressional warming. So that we saw that latent heat loss will be there. So because of that, there will be sinking of air. Hence, the eye temperature is higher than the surrounding environment. So that was the characteristics of eye, and this is about the eye wall. So eye wall will be surrounded by the violent regions. So eye wall you all saw that in the diagram also. Then it is a roughly circular ring of deep convection. Then eye wall region experiences the maximum sustained wind. This is what it will experience the maximum that fastest winds coming this part. Okay. So this is the eye wall. This part is the eye wall part. Okay, and here we have the eye part. So this is about that one. And all those tropical cyclones in all other parts where it is occurrence is happening, all those names are mentioned. In northwest Australia we have, Bay of Bengal side also we have. So all those tropical cyclones are there in these parts. And they are known by the different names that we all saw. But this is all about just for your knowledge purpose. These are not that much important, just for your knowledge purpose. And see, in the Indian Ocean, when you come to the Indian Ocean and in the Indian part, okay, in the Indian subcontinent part, see, we have a two sea. In the western side we have the Arabian Sea, and in the eastern side we have the Bay of Bengal area. But there what is happening, in the Arabian Sea we have the less formation of cyclones, whereas in the Bay of Bengal we have the more cyclones. Why? Because see, if you see the India map, this is a Bay of Bengal area, okay? If you see the India map, here what is happening? This is Arabian Sea. Here what is happening? Water are coming and sinking directly. So here in this part, they are sinking directly, okay? And one more reason is that here salinity is the high. And here we have only that less longest river. And this part we have that all those longest rivers are coming in this part. And this part what is happening? See, in the Indian side, in this Bay of Bengal area, in the other parts what is happening? In all that, if you go further this part, in the next diagram you can see. Okay, here you can see. So in this part, what is happening in these areas? So here we have the very less. In these parts, what is happening? We have very less land parts. Okay, means what you can see that we have Indonesia. So Indonesia, you know that there are many trenches in that. That means oceans are there. So here maximum waters are there. So from all those tropical cyclones taking place in the Pacific Ocean, they are not dying and they are reaching this part also in the Indian Ocean also. So in the Indian Ocean, in the Bay of Bengal area, we have the maximum number of tropical cyclones, whereas in this part we have less number. That means what? In this Arabian Sea side, we have only 20% formation of cyclone, whereas in this part we have the 80%. So see, everything I mentioned in this slide. So see here, the average annual frequency of tropical cyclones in the North Indian Ocean is about 5. So that means that is 5, average 5. So in that, if average 5 is what? 4 will be taking place in the Bay of Bengal area, and where in the Arabian Sea it will be taking place only 1. So that ratio is the 4:1. So light formation is there. And see, all those regions are mentioned. Why that only less formation of cyclones are there? First is that from, if you see from the behind part, we have the Africa part, Asia part also there. So from there, what happened? From there, cyclones are not coming. Well, that is the reason. Okay. And where from the Bengal side, if you see Bay of Bengal side, means from the Indonesia side, we have the Pacific Ocean. So from there also, all those are coming. Cyclones are coming. Then from this part, we have the long river flowing. All those long rivers, Brahmaputra, Ganga, Godavari. So there, because of that also, what is happening? Fresh waters are coming. Lot of fresh waters are coming. So because of that, there is no salinity in that part. That was salinity in the not there. But there in the Arabian Sea, salinity is there. So higher salinity is there. So because of that, we have the maximum number of cyclones in the Bay of Bengal area. So all these are mentioned, and these are important cyclones. All these parts are also mentioned in the slides. So these are the different cyclones. So this is about the different tropical cyclones. Okay, and how does the naming of cyclones happens? That also we'll see. See, only 4 minutes are left. If class got disconnected in the middle, you can leave. Okay, again we will continue the same topic tomorrow. Okay, because for NDA classes might be going to start. So if they start means early means our class will get disconnected. So see here, how the naming of all these parts are happening. See, there is a council. Okay, regional. That council name is, like you can say, the Regional Statistical Meteorological Center. Okay, name is that is located in New Delhi. So there, what they have decided that cyclonic name should be there. So in that case, what they have decided, that each country where the Indian Ocean is located, they should provide 13 names of the cyclones. So all the countries located near to the Indian Ocean, they have provided 13 names. Okay, so all these are the Indian Ocean's country: Bangladesh, India, Iran. So totally there are 13 countries. So totally 13 countries and 13 names they are providing. So totally we are getting 169 names. Okay, and all those country names are arranged in the alphabetical order. So that also you must remember. And all those namings will happen according to the alphabetical orders only. Suppose see, Bangladesh have given the 13 names, India also have given the 13 names. So now in this case, country's name will be arranged in the alphabetical order, and after that what will happen? They have provided the names. Okay, so they have provided names. Now this naming process will not happen according to alphabetical order. Only that country's naming arrangement will happen according to the alphabetical arrangement. Okay. Now, in which way? In say, like in orders according to themselves, they would have provided some names. So if they provided the first name as Nisarg, so what left? If the occurrence of cyclone happens in the Indian Ocean, then first country is the Bangladesh. So Nisarg will take place. So that cyclone name will be Nisarg. Now again, if the cyclone comes, okay, in the Indian Ocean, then Indian country name will be there. So that will be Gati. Then if again cyclone comes, then it will be Nival, and that will be named by the Iran. So in this way, cyclonic names are mentioned. Okay, so it will be first all these names will be mentioned. First all these names. Once all these names gets finished, then again when the cyclone happens, then it will start from the second column. Okay, from the second row again it will start. Okay, so if again the cyclone comes, then it will name that Biparjoy. Then again if it comes, the next it will be Tej. So recently we have the Biparjoy. So next it will be Tej, and it will be named by which country? This you all can easily see India. Okay, so in this way, tropical cyclones named are happening in the Indian Ocean. So this is all about the naming. Okay. Then next tomorrow when you come back to the class, we'll see about the all other parts of cyclones, and we'll see how that warnings are happening in the these parts. Okay, so that we see tomorrow. So okay, so that's all for today. We finish up the class, and if you have any doubt, you can ask me on the WhatsApp. Okay, and also at the start of tomorrow's class, there also you can ask. So there we'll see again those same parts if you have any doubt. Otherwise, we'll start with the temperate cyclone, and also we'll see about the warning system. Okay, so that's all for today class. Tomorrow we'll meet back again at the same time. So come as soon as possible, so that tomorrow we'll finish up the temperate cyclones and we'll start with the oceanography. So come back tomorrow at the particular time at 5:30, and tomorrow we'll meet again. So that's all for today. Thank you, and any doubt means you can ask me at any time.